Hey everyone, in this video what we're going to do is we're going to find the function f that satisfies the functional equation f of y is equal to f of xy plus f of y divided by x. Now we're given two key pieces of information. We're told that f is differentiable and that the derivative of f evaluated at 1 is equal to a, where a is just some constant. Now, the fact that we're told f is differentiable sort of gives us a hint as to how we should proceed with this problem. But notice we have two independent variables, x and y, so we could take the derivative of I respect to x or respect to y. What do you think would be a wise decision? Well, the aim of taking the derivative is to simplify the equation as much as possible. So if we take the derivative with respect to x, the left hand side is equal to 0, and we're just left with what we have on the right hand side. So what we'll do is we'll take the derivative of both sides of this equation with respect to x. Now the left hand side is just equal to 0 as we said before, and taking the derivative of f of xy with respect to x, we treat y as a constant and we use the chain rule. So we take the derivative of the outside part, we have f dash of xy, and we take the derivative of the inside part with respect to x. The derivative of xy with respect to x is just equal to y, because x would just go to 1. So we have y multiplied by f dash of xy, and we do the same for f of y divided by x, and we end up with minus y multiplied by the derivative of f of y divided by x, all divided by x squared. And if we add that to both sides of our equation, we get y multiplied by f dash of y divided by x, all divided by x squared is equal to y multiplied by f dash of xy. At this point what we want to do is we want to let x be equal to y. On the left hand side we have y multiplied by the derivative of f of y divided by y, all divided by y squared, and on the right hand side we have y multiplied by the derivative of f of y times y. Now y times y is equal to y squared, and y divided by y is equal to 1. So simplifying, we have f dash of 1 divided by y is equal to y multiplied by f dash of y squared. Remember, f dash of 1 is equal to a, so this allows us to rewrite the left hand side as a divided by y. And if we divide both sides of our equation by y, we have a divided by y squared is equal to the derivative of f of y squared. Now, of course, what we want to do is we want to solve for f of y squared, but it would be easier if we didn't have that y squared term. So what we're going to do is we're going to set y squared to be equal to t. So we have the derivative of f of t is equal to a divided by t, and we can integrate this. So on the left hand side we just have the integral of the derivative of f of t with respect to t, and on the right hand side we have the integral of a divided by t dt, and a is just a constant so we can bring it outside the integral sign, so we have a multiplied by the integral of 1 over t dt. Now the left hand side just equates to f of t, and the right hand side is equal to a multiplied by the natural logarithm of t plus b, where b is just another constant. And that is the final answer to our problem. Thank you very much for watching. If you have any questions or problems you'd like to see get solved in future videos, let me know in the comment section below. I hope you have a great day.